Hello everybody, my name is Craig Bennett, and today I'm going to get into mesh networks and the some things that a lot of people run in problems with, which is the speeds and stuff of this nature, but some common things you might need to know about mesh networks. The reason why I'm making this video is in a week or so, I'm probably going to get some Google Wi-Fi routers, and they are mesh network into itself. I'll explain a little bit more whenever I get them. But as far as that goes, I figured instead of waiting then and making a video on this topic, I might as well make it now. That way I can link back to it, and I don't have to extend that video out a lot longer than it needs to be. And one thing I found when I was looking up reviews on that Google Wi-Fi system is a lot of people, they fundamentally don't understand how mesh networks work in a constant, so being like the negative side of things. And it's just physics, and they're complaining about it being slower, but that it's just a thing that you got to worry with mesh networks. So and by the way, when I say slower, notes that it's a measurable slower. So instead of streaming something at 4K, you're streaming at 1080, or instead of streaming at 8K, you're streaming at 4K, or very close to 8K. It's really, it's like sitting someone in front of a screen between an 8K, 4K, and 1080. Most people can't tell the difference, flat out, unless if it's a graphics designer that will zoom into a lot of areas or something of this nature. There is like extremely high likely a person simply just won't know the difference between from the 8K to a 10K. Maybe some slight things, but 99%. There's enough tolerance there between monitors or graphics cards or something of this nature that a person probably won't be able to tell a difference at all. So as far as that goes, let's jump on in. So let's say, for example, with a normal Wi-Fi router, that's your normal Wi-Fi router, and let's say that's your computer. Well, normally what would end up happening is you'll have a direct connection and all that stuff, which is nice. The problem that I'm running into is I got a whole bunch of different little devices, wireless devices. This is a major thing people are going to run into in the future. Maybe you got wireless stoves, IP cameras, thermostats, so on and so on and so on. And by times it by 10 of this, and you probably got something close to what I have. So the thing is there is on all Wi-Fi routers is a device limit. You can easily hit it if you have enough. Basically, what happens on normal Wi-Fi routers is and this is just a physics thing, by the way, is Wi-Fi routers, they do only one of two things. It cannot do two things at once. Now, this is the exception if it has multiple antennas or something like that. It can do multiple channels and stuff like that. But it's a multi-in, multi-out. But as far as things goes, it's normally only does one of two things. So what ends up happening in a normal home Wi-Fi router, not enterprise, is basically it'll go to that device, see, are you there, are you there, are you there, are you there, are you there? It will go down the entire line and then go back to that device after it's done with the entire line. So what would end up happening is, say each one of these devices, they reply back at 1 millisecond. And this one right here at the very start, it replies back at 50 milliseconds. Well, what's happening is now all the devices, even though they all reply back at 1 millisecond, this one device, since it's 50 milliseconds, the router or extender, depending on what you're using, will slow down to 50 milliseconds or whatever the slowest is. So this means that, your internet connection, your Wi-Fi connection, not internet connection, your Wi-Fi connection is slowed down. And this does affect the internet connection, by the way, but your Wi-Fi connection is slowed down. And that's why you need multiple channels and stuff like that. But most home Wi-Fi routers don't have the ability. They only have one because they're cheap. So basically, you're going to be slowed down to the slowest device on the list. So let's say your stove is 200 milliseconds. Well, each device will slow down to 200 milliseconds, and it's possible to actually get some of these devices start timing out, because let's say that all these devices are at 1 millisecond, all of them. Well, let's say there's 400 devices and your device is somewhere in the middle of that. Well, it talks out to your device. Now, 400 milliseconds later, it'll get back to your device. Then 400 milliseconds later, it will get back to your device. So basically, what would end up happening is your device, it will only be able to send a packet out every 400 milliseconds, give or take, depending on the the router and whatnot. But that's pretty much what you're going to be dealing with, is a massive latency. So that's just and that's the best case scenario if you got 400 devices. You're going to have timeouts and all that other jazz with it. So there's that. But the thing to note is you're going to run into some major problems if you got too many devices. Now, not only that is if you got devices, say, way out here, that will slow down your entire network, because again, the latency between that and here will affect all of the others. So if it has a 200 millisecond latency, then all the others will gain an automatic 200 millisecond latency. So that in itself can slow down your entire network. And then see what happens is if you have, like, say, 3 IP cameras and then your laptop, if they have a pretty bad latency, so what? It gets back to your laptop so quick that you will only be able to tell the difference if you're measuring it. Like I said before, where a mesh network, it will slow down the overall, but if done right, yes, it will slow down, but you're still streaming at 4K, but it's just a couple megabytes slower. Or instead of going from 130 megabytes, you're going to 100 megabytes. Yeah, it sounds like a big drop, but are you really seeing it when you're just getting emails and stuff? If you're just doing a doctor's office, are you really seeing it? You're not streaming or anything, or you shouldn't be. But I mean, just regular whatever, that could take effect or whatever. So the thing to note is the amount of devices and the speed of the devices can greatly affect things. Now, there's other problems that can play. Is, let's say, for example, if you have an extender, say for example that your laptop is very far away. Well, you can use the extender to get out there, but the extender itself, I've noticed, can have major problems to itself. So one of the common problems that you find with extenders, let's see if we can draw a main Wi-Fi router and the extender. Well, what you can have is your little laptop. Oh, you just walked from your Wi-Fi router, and then it will actually disconnect from the actual main Wi-Fi router and connect to the extender. We all know it takes a long freaking time to connect to another Wi-Fi source, which majorly affects streaming and some other things. Like if you're watching YouTube videos and it's all buffered out, that's one thing. But for the most part, what's going to end up happening is you're going to run into a problem where you're streaming something, playing a game or whatever it may be, and you're just walking along with your phone and you lost connection. That's a problem unto itself. You might say, okay, let's name them both the same SSID and also the same password. which I've actually tried this out. Sometimes this does work. So if you want a poor man's solution, sometimes that works, but a lot of time, like it works for very particular situations. So try it if you have the ability. Maybe it'll fix your situation. I mean, if you already got the equipment, fine. It's not costing you anything, just a little bit of time. But I would not buy a extender for this particular thing. Basically, what you end up having is your extender, if it's named the same and everything else, you still have to basically disconnect from one and connect to the other. And what's going to end up happening is your laptop, and I've personally seen this, where it will compete against each other, especially if they're about the same or whatever it may be. It'll start competing with each other, and you'll play around with this for about 2-3 minutes. It'll knock off, go to that, 2-3 minutes, knock off, go back and forth, back and forth, back and forth. And you can't play any games. You can't do any streaming. You can't do much of anything without having major problems. So with that being said, basically that's a bad idea into itself. And then I've seen it where you even if you don't name them the same SSIDs and passwords and whatnot, but the computer is associated with both, well, what would end up happening is I've seen it where if you're somewhere in the middle, it will start bouncing back and forth. I've seen that a few times on a few devices back in the day. So that's something to note. That's possible. Now, what Mesh Networks does is you got a home base that'll be connected to a modem or something. Then you have something in your living room, something in some other room, something over here, something over there, something over there, something over there. And then eventually you're somewhere over here. Basically, what would end up happening is the mesh network, if it's properly set up and everything, you will connect to one, and these two or whatever's closest will actually say, "Oh, I'm at 90%. I'm at 100%." Because one thing to note with your laptop, so your laptop says, "Oh, I can see this device at 100%, but I can see this device at 80%. Well, your laptop, anything that has Wi-Fi ability, is a router in a sense, is an access point in a sense. Basically, not a router, it's a access point in a sense. Basically, it receives and transmits, but it can only receive and it can only transmit. But the point I'm trying to make here is while you're able to see this at 100% or whatever it may be, well, the thing is you're, for whatever reason, it might be the power from your device. I've literally seen wind cause your radio signals to show up better on one versus the other. Just regular devices, just testing out and stuff like that. Things like that, things you can't explain, like just weird crap. You'll find that it'll show up better on one device versus another. Like it'll move around when or something. So stuff that you really can't explain unless you put like some massive science behind it, and even then, it's very difficult to explain because it's here and now type of thing. But basically, what ends up happening is your device. There's a possibility that it can see this, the access point, because it's putting off enough power into its radio signal, but your device does not have enough power, so the access point won't see it. Or in some cases where it would see it, it's possible like some wind or something is making it where, oh, this is seeing your device being at, I don't know, 40%, but this is seeing it all the way up into 80%. But your device is seeing this to be in the 100%, but this is showing up in the 60%. Well, this will say, oh, I can see the device a lot better. And basically what will end up happening is it will go ahead and try to say, connect this particular one to that. And what it would end up happening while it's doing it, because all of these are communicating with each other, given that they can see each other. It's very important to note this. Basically, the closer ones have to see the home base. Basically, there has to be something over here that gets to the home base. It might be this, and then for some weird reason, you set it up like that, where that can see the home base, but not that. So it only has to do a hop or two versus going all the weird routes. So note that. But if it has to go, if this can't see the home base, but it sees, oh, that can see the home base, that can see the home base, then it goes down, then we'll do that. Whatever is the best. It's a self-healing network, and I'll get more into that in a second. But basically what will end up happening is it will basically look for the best route for the home base. From there, basically, you can transmit through all these hops. Now, it's very important to note that you don't want a lot of hops, and I'll explain a little bit more on that in a second. But let's explain a little bit on the self-healing since I got this up. Well, let's say all of a sudden, I don't know, it's trying to reach out to here. Oh, this one goes down. Now it's going to switch over to that, and that's going to self-heal and, automatically like that. So it's like the VPN video I done a while back, where VPNs are self-healing. Basic internet's like once you get past your internet service provider, between your internet service provider and wherever you're sending the signal, it's self-healing just like this. This is a very fundamental thing that you'll see across the entire internet, but it's self-healing. So let's say that this gets some water damage. Well, it automatically just stops working out in the middle of nowhere. Well, this will detect, oh, I can't see that anymore. So what will end up happening is it will see that and say, well, you can see that, and that will fix the entire thing right there. So that's just something to note into itself. Now with mesh networks, note that, say you're talking to the home base, it is not going through multiple, let's call it, pipes. So for example, if this is the quickest right there, it's not going through this and that. It's going through the quickest only. So note that. Even though that this other is a backup and it can potentially be created on a snap, the fact is when you're transmitting, it's only going down one pipe. This is a fundamental thing to deal with packages, and you don't want packages to be split up. This is a security thing into itself, but on top of that, you got redundancy. So basically, you'll get your computer to send out a I don't know, maybe you're playing a game and your everything's on the web server base, and you told your person to move right. Now it moves right 2 times or 3 times if it's 3 pipes, or 4 or 5 or whatever. So you can obviously see where you don't want to have the thing going down multiple pipes. It goes down one pipe or the other. And you might ask, okay, so the package is going down, let's say it's going down here, and it's going to this one, but all of a sudden this goes out. Basically, the package is stored at this, and then whenever this gets healed up, it will be sent on its way. So your package is not lost. If you get a bad mesh network, I imagine that's possible where it might be lost, but it's that you're really talking about like 1990s technology when hubs were in use in full swing. Basically, this would not be lost. This is fairly old technology to keep packages and to basically sort through stuff and wait for traffic to go through. So basically, and I mean, this is a fairly basic thing and very common for any type of router. So basically, what would end up happening is, let's say that you have a TV over here. Someone's watching it, maybe streaming something. So while you're doing your thing on your computer, someone's on TV. So what's happening is, say you send a package from here. They send a package, and it hits that same time. One of the packages, because keep in mind, you can only send out or receive, but it cannot send out and receive. And it can only send out one at a time. And yes, it's even though it's light speed type of stuff, it's one at a time. So basically what would end up happening here, this will actually store either a TV stream or whatever it is, or whatever you're doing on your computer, maybe games or porn or whatever. So it's fairly important to note that this will save the actual package. It's a very small save, but it will save that as it's going through. And the more devices, it can save. It's automatically dumping as it's releasing it. So say, for example, you're on your computer, you're doing games, you send it's a web server based game. You tell your person to go right. Well, once it sends that command, that right command out, once it hits out, it deletes. After there's in some cases, what would end up happening is from here to here, there will be a signal back saying, I got that. And then at that point, it will delete it. Otherwise, it'll keep trying. Otherwise, you'll run into the problem and say, oh, that connection's gone and it already deleted it. So note that what ends up happening is you tell your person in game to move right. It sends it to here. It waits for this to send a signal back real quick to say, I got it, and then it deletes it. But if it doesn't get that, I got it, it sends it, and then gives up and gives you a timeout. Or being in mesh networks, what it will do is it will see what else. It sends it. It waits for different manufacturers. Going to be different. So I can't. This number is going to be arbitrary. Just note that. But it sends it. It waits for 100 milliseconds. Oh, it doesn't hear anything back. Now it goes through a different path. And that's fairly important to note. That way you know that if this is has multiple things, it can work. And this is actually what network engineers have to know, by the way. So if you're going for like Cisco type of stuff or Juniper or whatever, that's basically a very fundamental thing to know. By the way, if you enjoy that might be a career path for you. But what would end up happening is again, if this sends it out, then if it doesn't hear anything back, it tries to do self-healing and it sends it out to some other method. So that's just something to note. I don't know for a fact because again, different manufacturers do different things as far as one might be 10 milliseconds, the other might be 3. But I would imagine if normally, say, for example, the connection between this access point and that access point is, let's say, 3 milliseconds, I imagine it times it by 3. So if it's 9 milliseconds, then it'll say that it's not going to get it, so it will send it to something else. Usually on a normal router switch, what would end up happening is it'll send it, didn't get it, it'll send it again, didn't get anything back, and then it will send it one last time, and it didn't get it, so it will go off and send to something else and go by that method. Or you might notice on a computer when you're pinging, it might be like 4 times. It'll time out, and then it'll say, "Oh, nope." Again, different manufacturers do the different amount of times it will cancel out. They usually it's 3 or more. I've seen it into 5, but which is common, I think. But as far as the amount of time, you can actually on Windows and some other things you can manually adjust this. I know you can adjust into 300, 400 milliseconds easily, more or less if you want. But in Cisco stuff, you can also adjust that. So I can't tell you what's the normal. Just note that it will be different from each. But I mean, this stuff happens like that. It's milliseconds time. But before you have time to figure out what's going on, it already has the thing done. So that's the thing to note with that. Now, as far as the problem here goes, is let's do a clean slate here. Is let's say that we have a home base, 1 access points, and another, and let's do one last one. Well, what's happening is going from one end to the other. What happens is if you connect to this one, then basically, let's see if I can get these stuff. You will reach 100% of the efficiency. Actually, if you go to this one, it's 100% efficiency. This is 50%. Then here is 25%. And then let's say, for example, there is a latency. Say this is a 50 milliseconds latency, which basically means that it takes 50 milliseconds to communicate. Here there's a 100 milliseconds latency, and then here, let's go a little bit more. Here there is a 200 millisecond latency. That's fairly important to note. And that means that you wouldn't want to put your voice over IP all the way down over here. There's ways to fix it. There's ways to actually fix this problem. I'll get into that in a second. But the thing is you need to note that the more hops it has to go through for you to connect something, because here's the thing. Here's the neat thing with the mesh networks. Say you go around this one, oh great, you move to the next one, and as you're going through from one access point to the next, you don't know. Your device automatically switches. Basically, by its own, basically a good mesh network, what would end up happening is as you're moving through, it will see, oh, this one has a higher signal rating, so it will automatically kick over and say, hey, take this, and then as you're going down or back, it will kick over. Now, you might have been in some hotel, maybe Hilton, Hampton, or whatever, Marriott or whatever, and you probably played on your phone, or maybe had a kid that played on the phone, or whatever it may be, and you might notice that you don't lose any internet signal going from one side of the building to the next. Well, this is caused by the mesh networks into itself. It's enterprise level. It's a little bit different, but basically it's the same thing. Basically, as you're going from one thing to another, it patches off and tells this one to pick up the stuff for you. Keep in mind that's because what would end up happening is as you're going through, the device that you have will be just hopping through, and you won't be able to tell which one you're on. The only way to actually tell how many hops you're out is by looking at the milliseconds. This is given that nothing else is on the system, which obviously is not going to be possible like in a hotel, hospital, whatever. But as far as that goes, that's just something that you got to note is the more hops you're out, the slower it gets. How you can fix this is enterprise level or some, obviously not home versions right now, but enterprise level. Basically what would end up happening is by it gets to 3 hops, 4 hops out, you'll have some wiring. This will be connected to a modem, and then it will continue on the signal. So every 3 or 4 hops out, it will connect to a modem, and that will be that. It'll be something simple as that. I've seen them. It's not often like this, but I've seen them where they're all connected to a modem. I've seen it in many hotels. It's not often to see it in most other places, so just note that. But so in some industries, that's a fairly common practice. Others, not so much. I think it's fairly common practice in hotels because they have more access to do things like that. Whereas in cities and things of that nature, manufacturing, sometimes you get that, but not really almost ever. Most of the time, you don't have that ability in most places. But what would end up happening is somewhere down the line, you would end up happening. So say, for example, you down the line, you put a modem, and then it'll just go on, and what would end up happening is the mesh network. It will look at the MAC address. It's a whole detail thing. Just get into it real quick. If you don't know what MAC addresses are, look that up. I don't want to explain it in this particular video because it'd be a little bit long. But note that each device has its own independent MAC address. No 2 devices in the world is supposed to have matching MAC addresses, but I personally don't believe that because, I mean, the probability of multiple devices having the same MAC address is fairly high. And actually, I think has been proven that each device having its own MAC address has been proven false. But as far as this goes, the chances of this device and that device having the same MAC address is fairly low. So what happens is basically, since each device has its own MAC address, basically it knows that for here, get the internet from here. For this, get the internet from that. Through the MAC address, it goes through the software and the self-healing part. And if the internet somehow goes down on this, then it knows from here, get the internet from this. So everything is dependent on this one. And it's just a redundancy factor into itself. So you can build in that in many enterprise level ones, or if you want to build your own system. But as far as home use, that's not the case normally. What would end up happening is let's go ahead and build another thing. Is what you have is so you have your mesh network over there, and then you'll have an error mesh network over here. What would end up happening is, so you got a mesh network over here, you got a mesh network over here. So like maybe you have a mesh network at your home building, and then I don't know, maybe you got a shop right next to your building, a greenhouse or something like that. Basically, what would end up happening is you can do a few things. What you do is you take the modem, you hook it up to that. So basically the modem, it hooks up to the mesh network at your home. You also hook it up to a line of sight. And what a line of sight basically means is if this device can see this device by visual sight, which means that in weather conditions or a tree or something like that, it won't work. So if you got a hurricane or something like that, it won't work. But with that being said, you can do a line of sight. You can do, let's do a regular router and an extender over here. I've actually seen that, and it's very reasonable, where you can actually have a regular router and it will transmit to the extender. The extender will have a mesh network hooked up into it, and basically what would end up happening is anything in the mesh network will go into the extender. The extender, you can actually have it on some of them where the radio is turned off, but it basically does a hitting thing where it's really on, but it's meant so if you don't want your list to be clogged up, but you want the router still communicating with it, going back and forth, you can do that. But basically what would end up happening is the extender, it'll be connected to the mesh network over here. The mesh network will do its thing and it sends its information through the extender that will go back to the router, which will go back to the modem into itself. Or maybe the router is connected to the mesh network over here, which will go to the modem itself. It's a fairly common setup. You can also do things like power over electrical lines, which is not common for something like this. Tends to be a bit much for something like that. There's a few things you can do, hardwiring from one area to another, but there's a few things you can do. It's just good to note that it's not a good idea to put like a mesh network going all the way across and then, doing that type of aspects. Having a mesh network, so having a mesh network, say for example, if you got a home and you got a shop, a greenhouse over here, and you got a path going to it and you like to walk down it, maybe you have a bench or something like that you want to sit down, but the mesh network over here and the mesh network over here doesn't give you enough signal, and you don't want to use a router. Maybe you got the thing hidden so it doesn't actually, if you have guests, they can't connect to it or see to connect to it. They can still connect to it if they know the stuff, but they won't be able to see it. So what you can do, and if you want the mesh network quality out here, you can connect the most routers. They will have multiple ports on them. You can connect the mesh network to it, do a direct connection to one or more of them. Same thing with that side. And basically what ends up happening is the access points, they will give the internet from the router itself. This is a enterprise level that does this. I can't promise Google Wi-Fi that will do this, or any home Wi-Fi would do this, but enterprise level, you can definitely do this. Basically say only get the internet through this Ethernet cable, and basically they'll transmit and they'll act as a mesh network for all these other things. In many offices, you might see something, I know I'm getting a little bit too deep into this, but you'll see something like this where you'll have a bunch of little access points hanging off of it. And basically what happens is, let's see if we can draw some access points on there. So basically what would end up happening is basically between the two devices, they will transmit to each other, but a mesh network will be its own quote-unquote independent network. Note there is a potential for jamming. What causes jamming is basically too much noise, too much signal on the same frequency. Basically, think of it as if you're talking along with 3 billion other people talking in a small room, and you're talking to someone else and they can't hear you. It's the same thing. Basically, all the other noise, it's equal to or greater than what you can send out. So basically, it's potential that you can have all this being equal to each other. and this will interfere with each other. So, say for example, if you got a lot of routers out, a lot of stuff out, you can actually have it where it's all equal to, and it'll start jamming each other. And then you can also have it where, say for example, something's greater than and overtaking, kind of like if you're like in a nightclub and you're trying to talk to someone that's right next to you. It's not going to happen because the speakers are so loud. Well, it's the same thing. If just note that it's radio signals instead of regular sound. But waves are waves. It doesn't matter if it's sound, or if it doesn't matter if it's water, or if it doesn't matter if it's electrical waves being radio signal, which is electrical, or lights. If it comes in contact, direct contact with equal force, they both kind of cancel each other out. There's side shoots and whatever, but then you have greater force. The greater force will always overtake the lesser force, but it will start becoming a lesser force itself. So you can dramatically diminish something. So you can take 50% of the force out, but still it would take your signal out to one of the signals that you wanted, or all of the signals that you want, depending on the situation. That's actually how jammers work. That's why you can have a jammer the size of a lighter or something like that. Something very small, like a pin or something. It doesn't take much. All it is sending electrical waves, radio waves, out at such high volume that it either overwhelms by being quote unquote louder, by being sent out in high volume, or being equal to, and it cuts in and out. It's kind of like a radio, cutting in and out, cutting in and out, cutting in and out, and you're going between two stations. It's kind of like that, where the two stations are balanced against each other. One's not equal to, one's not greater than the other, so you'll get static. And once in a while, one will be greater than the other, so you start hearing it. But if one is greater than the other, then you're only going to hear that one. That's the best example pretty much anyone can give you is like the old time radios, not the Pandora or whatever we got today. We'll try to use today, but back in the day, and a lot of people still today, they use the old radio frequency radios. And if you got two radio stations playing, they both put out the same stuff. Basically, the same. It's on the same channel. Basically, what would end up happening is if they're equal to, you get static until one's greater than the other. And the better that one is than the other, the less static you get. So you might notice that if you're playing around with this, maybe on AM or AM, whatever it is, I think it's AM FM. You might notice that you still get a little bit of static when you're listening in, but you can tell that they're compacting each other. But that little bit of static is caused by that greater one is diminished by a bit by fighting the lesser one. And then whenever the one of them wins, whichever it may be, you can, and to a great degree, you will be able to hear it. Note that there's always background noise, and all these signals are fighting against it. Even Wi-Fi signals are fighting against that. But the Wi-Fi and whatnot is much more stronger, and there's no point of an average person knowing it, because they don't have to worry about that. So note that battle always happens. There's no time it doesn't happen that we know of. Obviously, this just getting off a little bit. This actually goes into the Big Bang. It's what believe the static and stuff that's actually caused by residual information from the Big Bang Well, and basically that's the background stack you see on TV or whatever, the old time TVs or whatever it may be, is the residual electrical energy, and it's very, very, very low, and basically it's if that goes away, then there will be no real background noise, except for the background noise that living creatures or other things, machines and whatnot, create. So it notes, yes, people, frogs, whatever, they have a electrical charge that radiates from them, and that's kind of like the tool, the instrument that you play with waving your hand over it. It's the pheromone. No, not pheromone, but whatever it's called. That's how that works. Is you're actually disrupting whatever. But anyways, going off topic or whatever. The thing to note here is the con of it is, like I said, with the signal loss between each hop. This creates it where instead of streaming in like 4K, you're now streaming in 720. But if you're like doing emails or even playing games, you might not even notice really at all. But just note that there is some cons to this technology. Like everything, there's a good and bad to it. The better the good, the worse the bad it tends to be, not always. But the thing to note is that the good with this is, I don't think I showed this, is what you can do is, instead of having one device that has a contact to a billion little devices, what I can do is have a whole load of mesh networks, so that one connects to that, and that. This one connects to that and that. And the reason why this is important is because, like I said earlier, basically for this access point, it'll talk to that, then that, then that. It'll be slowed down to the slowest, but it has to talk to each one. And since it's just talking to those three, there's not much to worry about. And then since these are just talking to that one, it takes the pressure off of this one right here. That's a very important thing, because, like, say for example, if you got 40 different cameras or whatever it may be, well, basically if you get one access point to talk to, I don't know, several access points, so you talk to only five of them, well, it only has to focus on getting around to seeing if those fives are still there, and any information it transfers back like normal, like it would, but it has the actual potential to increase your actual overall speed, because if you got one device trying to talk to like 400 things, it'll be much slower, whereas if you have, say, 20 of those little devices talking to the 400 things, the workload is split up to some degree between those 20 different access points, which means that it will actually increase it simply because it takes the workload off. Not so much because of the speed of the devices. Notes that in order for a effective mesh network, well, effective network at all, the entire network will have to slow down to whatever it is. So for example, with something like this, say if there's a device out here and you got I don't know, this right over here, it is this is 200 milliseconds. All these devices are going to be slowed down to 200 milliseconds, like I said before. But once it hits that router, anything on the other side of it that's connected directly to the router or going through and connected to that extender, that isn't going to be 200 milliseconds. That's going to be whatever it is, because it's through the Ethernet, basically from this thing right here, this access points, it goes into the Ethernet and goes into the router. And the this is the great equalizer, is the actual Ethernet ports. So just note that where if you're connecting, like say for example, like here, you might be slowed down in this particular division of a building by, I don't know, 20 milliseconds, but this you're down to 1 millisecond of latency, because basically all of these, the access points, if they were connected to each other, basically what would end up happening is they would end up having to slow down to whatever the slowest is. But once it gets to the router, it since it's connected by the Ethernet, it speeds right back up. So as far as that goes, that's just something to note. It's a lot more detailed than I originally planned for. And let me know if you stuck around the entire thing. But anyways, leave a like, subscribe, share, and see you next video. I hope you have a great day.